Chapter 6, Lesson 4 of Advanced Algebra, we're going to continue our look at solving polynomial equations. And again, we're going to look at factoring, and as we've been talking about factoring quadratics, we learned how to do that. We looked at factoring cubics. There's some special cubics that we could factor. And in this video, we want to look at factoring quartics. And again, factoring of polynomial equations of fourth degree or quartic polynomials isn't always that easy. However, if they are in a certain form, then we can use factoring rather easily in order to solve that. So we're going to look at that special type of quadratic when we're looking at a fourth degree. Now, these special fourth degree polynomials have to have one thing in common. This first term has to be and is going to be a fourth degree. The middle term needs to be a second degree, and then the last term can be a constant. As long as it's in this form, the method that we're going to show will work. If you have other terms involved, if you have an x cubed in here, then this method won't work. So just keep that in mind. These are for some very specific type cases, but whenever you see an x to the fourth, you'll want to think about using this method in order to solve it. All right, so let's take a look at an example at how we can factor these quartic polynomials. So for this example, this does fit our criteria where we have an x to the fourth term first, and then we have an x squared term second, and then we have a constant. Now in order to do this, we're going to take this quartic polynomial and use a little bit of algebra imagination here a little bit to turn it into something that's a little bit more familiar with us. In other words, I could turn x to the fourth into x squared squared. That's, if I multiply these, that's still x to the fourth. Okay, and so then I could put this in. This is then 7x squared plus 12. Now how does that help me? Because here's what I can do then. Let's say we're going to use a, and we're going to let a equals x squared. So instead of this x squared here, I'm going to put a. So this is going to be a squared. And instead of this x squared, I'm going to put a. And then I have this. So now what do we have? Well, now we have a quadratic, which we've done a lot of work factoring with. So we can factor this quadratic. Because this is a coefficient of 1, I know this is going to be a and this is going to be a. Then I simply need factors of 12 that add up to -7. So that's going to be -4 and -3. So turning it into a quadratic allows me to factor it quite easily. Now I'm going to take a and I'm going to put the x squared back in. So this ends up being then x squared minus 4 times x squared minus 3. And so now I have this fourth degree polynomial factored using a quadratic model. Then, if this was equal to 0, if this was an equation, let's go ahead and do this. Now I can apply the zero product property to finish off and figure out what makes this 0. And again, all I have to do, these are now quadratics without a linear term, which I can solve by extracting the square root. So I want x squared minus 4 to be equal to 0. So I simply move that to the other side and then take the square root. So I get plus or minus 2. And then I do the same thing here, x squared minus 3, I want it to be equal to 0, so x squared is equal to 3, so x would be equal to plus or minus the square root of 3. So I have my values that solve this equation using a form of modeling, or a form of factoring, excuse me, where we take a quartic, we turn it into something that looks more like a quadratic, factor that, and then we put the x squared back in, and now I have a factored form of the polynomial which I'm able to use to solve. Okay, so that's how you can solve a quartic polynomial. Again, if it fits this very specific scenario, but it is a way to do it. Let me do one more example that we would consider to be a hard example, and then we'll wrap this lesson up. Okay, in this example, we have on the left side, we have our quartic polynomial in the form that allows us to factor it. So you remember, I'll write this step in, even though you probably wouldn't have to if you don't want to or need to, I could rewrite this x to the fourth as x squared squared minus 2x squared, and then I'm going to move this 2 over here and set this equal to 0 because, again, I want to be able to use the zero product property once I have this in factored form, so I'll need to put it over here before I factor it, and then I can use this number to factor. Now you remember, we're going to let the letter a equal x squared, so I'm going to take this x squared out and I want to put a in instead. I guess I don't need that parentheses anymore. So this is going to be 4a squared minus 2a minus 6 is equal to 0, and now I'm going to factor. Now I notice here that these have a common factor of 2, so I'm going to factor that out first. So that's going to give me 2a squared minus a minus 3 is equal to 0. And then I'm going to go ahead and factor this quadratic inside here. So I know that this is going to be 2a and a, and so then I need factors of negative 3 that will help me add up to negative 1 here. So let's see, if I make this a positive 1 here and this a negative 3, that should do the trick. So 2 times a, 2a times 1 would be 2a. That's the outer, and then the 3a multiplied together would be negative 3a. If I add those together, I get negative a. So this would be the factored form. And now I'm going to put the x squared back in. So this is going to be 2 times 2x squared minus 3 times x squared plus 1 is equal to 0. So now that I have factored form, I can use the zero product property to determine what makes each one of these factors 0 to solve the expression. All right, well, this factor 2 can never be 0, so there's nothing I can do there. So I need 2x squared minus 3 to be equal to 0. So what would that be? So we'll solve this equation, move 3 to the other side. X squared would be equal to 3 halves. So x would be equal to the square root of, plus or minus, 3 halves. And then if I were to rationalize that, I would get x equals the square root of 6 over 2, if you rationalize that. Then this last factor, x squared plus 1, I need that to be equal to 0, so that's going to be x squared is equal to negative 1. So x would be equal to positive or negative the square root of negative 1, which we know is I. So x would also be plus or minus I. Those would be my other two values that would make this 0. So in this situation, you'll need to move the constants so they're all together and equal to 0. Then you can use that quadratic kind of method of factoring that quartic, and then put the x squared back in at the end, and then you're able to solve that equation for 0.